last video, I explained to you how to evaluate the integrals consisting of the trigonometric functions directly. And now here in this video, I will tell you that how to deal with the same kind of the question with the u-substitution method. If you will be able to solve the questions directly, it is good. But if they are asking you to apply or show the work, then you have to use the long method. So the first thing is that whenever you look into the question, you have to find out the complex function. Now here you have the two trigonometric functions, and in one of the trigonometric function, there is a power. So always consider that function as the complex function. So the complex function is sine x whole square. Now in that complex function, sine x is your inner function and the square, that is the power, is your outer function. So name the inner function as u. So write u equals to sine x. Once it is done, take the derivative of this function. So you will get sine x, the derivative of the function is cosine x. Bring the dx on the other side, you will get du equals to cosine x dx. Now write all the integrand which are written in terms of the x, write them in terms of the u. So here sine x you named it as u, and this power 2 you will write over here. Cosine x dx changed into du because you find it out. Now it is a simple and normal function, that is u squared du. So whenever such kind of the question, you will apply the power rule. That means you add 1 in the power, so 2 plus 1 will gives you 3, and divide with the same number, that is 3 plus c. Now in the end, convert the u again to the x form. It means u will be changed into sine x, which you already imagined in the start. So sine x whole power 3 over 3 plus c. So this is the way we can solve it in the long way. Now let's solve another kind of the question. So look at the second question. Here the complex function is cos cube x. Why? Because it has a power. So consider the inner function, that is cos x, as u. Take the derivative with respect to x. So the derivative of cos x is negative sine x. After that, bring the dx on the other side. So you will have du equals to negative sine x dx. Now if you just compare the first part, that is u equals to and du equals to, with the question, you will see that cos x, write the integral sign and convert all the x value into u values. So cos x will be written as u, the power will be written on the top of the u. Now sine x dx, and here on the second side you have, on the other side you have negative sine x dx. It means in the question you don't have the negative. So in that way you bring the negative on the other side by dividing negative 1 with both sides. You will get negative du equals to sine x dx. Now sine x dx will be converted into negative du. Write the negative before the integral sign and du at the end of the integrand. Now again apply the power rule. This negative which is outside the integral sign, write down as it is. Add 1 in the power, so you will get u to the power 4 over 4 plus c. Now convert the u into x values, that is cosine x. So in place of u, you will write negative cosine x, or you can write cos to the power 4x over 4 plus c. Now, now check another question, the last question which is written here. 10 cube x sec square x. So suppose you are taking sec x as the function. So let's see, inner function is u, which is equals to sec x. So the derivative of the du by dx will be sec x tan x. Now if you are going and bring the dx on other side, you will get sec x tan x and dx. Now convert the whole integrand into u form. Look at this now, this question, look at this. Now sec changes into what? U. So you will have u and this square will be here, power 2 and dx. Now dx and 10 cube x. Dx and 10 cube x you don't have here. So it means you are in the middle of the way. So you cannot apply in such cases u-substitution method. You have to apply something else. These will be done with the help of the trigonometric substitution. But in order to apply the u-substitution method, especially when you are dealing with the 10x and secant square x, take the 10x as the inner function and check. By taking the derivative with respect to x, you will get secant square x. So see, you are standing at the right place because you get the derivative in the question. And you all know that we apply the substitution method if and only if the derivative of the inner function of the composite function is written in the question. Now change the whole integrand into u form. So 10 cube x, you will get u to the power 3. Secant square x dx can be written as du. And it becomes so simple. Take the antiderivative using the power rule. So you will add 1 in the power. So u to the power 4 over 4 plus c. And in the end, replace the u by 10x, which you already imagined in the start. So you can write 10 to the power 4x over 4 plus c. That's all. Applying the u substitution long method over here, the first thing is bring the cosecant power in the cosecant to the cos x to the power 5 on the top. So you will get sine x cos x whole to the power negative 5, because when you change the place of the function, the power sign will be changed. So here you can see that cos x with the power something. So you will consider it as a complex function, and here the cos x, which is written inside the bracket, is your inner function. So name it as u. After that we take the derivative with respect to x, which will gives you negative sine x. Bring the dx on the other side, so you will get du equals to negative sine x dx. Now negative is not present in the question, so bring it on the other side of the equation. You will get negative du equals to sine x dx. Now convert the whole equation into the u form. So cos x will change into u. So you will write u whole to the power negative 5. And now sine x and dx, in place of this sine x and dx, you can write it as negative du. So negative always write in the start and du at the end of the equation. Now apply the power rule simply. So this negative you will write as it is, add 1 in the power. So you will get u to the power negative 4 divided by negative 4, and at the end you will write plus c. Now u will be changed into cosine x. So in place of u, first negative 1 divided by negative 4 will gives you 1 over 4. So 4 here, and u to the power negative 4. So u will be cosine x whole to the power negative 4 and plus c. You can write the negative power as positive by bringing the cosine x in the denominator. So you can write it as 1 over 4 and write the cosine x as it is in the denominator, but change the sign of the cosine x. It means when you bring it down, the negative changes into positive by using the property of exponents. Now after this, let's one more last example. Do it so that it will become so easy for you to solve or to deal with such kind of questions. Again, you should know that if something is written with some power, for example, if f of x is written with the square root, you can write it f of x as a power half. Now, similarly, if f of x is written in the cubic root, you can write it as f of x with the power 1 over 3. Now, if something is written f of x here it is considered as the out, and here there is a power in. So, you can write the function as in over out. So, remember in over out. So, write down this integral sign as cosec square x, and down is your cot x. Write it in terms of the power. Inner power is 5 and outer power, if nothing is written, then automatically it is 2. So in over out means 5 over 2 and dx. But whenever we integrate, we have to bring the function on the top. So the function can be written as cosecant square x cot x whole to the power negative 5 over 2 dx. Now negative 5 over 2 is a weird thing, so always consider that function as the complex function. So in such case, your u will be cot x, because cot x, you are considering cot x to the power negative 5 over 2. So I am writing here. So u will be your cot x. So the derivative with respect to x of the cot x is negative cosec square x. Bring the dx on the other side, you will get du equals to negative cosec square x dx. Since you have no negative sign in the question, so it is very good act to bring the negative on the other side. So you will get negative du equals to cosec square x dx. Once it is done, convert the whole question into your u form. So in place of cot x, you can write u and the power as it is. Now in place of cosec square dx, you can write it as negative du. So negative in the beginning and negative in the beginning, anywhere you can write, and du as it is. Apply the power rule. That means you add 1 in the power. So negative 5 by 2 plus 1 will gives you negative 3 by 2 upon negative 3 by 2 plus c. Now if you write in the calculator negative 1 divided by negative 3 over 2, it will gives you positive 2 by 3. Now u has a negative power, so write it down in the denominator to make a positive power. Now replace the u by cot x, because in the start you already suppose that u is your cot x, and write down the power 3 over 2 plus c. So that is all how we can solve these kind of functions by the long method of u substitution, or in the previous video I already explained how can you deal with these kind of the question without applying all these steps. In one step you can write down the answer. I hope that now the case 1 of the trigonometric functions is clear to you. If there are any questions, just send me the message.